Hello and welcome to the special Christmas/end of year episode of the Obscast. My name is Joe Gathercole, and this evening we're going to be looking back at the year gone as well as forward to the year ahead, both in terms of the society here at Sherwood Observatory and in astronomy in general. I'm joined on this episode by what I like to call the Obscast team. That is the group of MSAS members who come together so the Obscast can exist and grow. And I think if we go around and introduce ourselves, then we can get started with some of our favourite memories from the year gone before moving on to some things we're looking forward to the year to come. So if we start on my left with Rob.
Good evening, Joe. My name is Rob Dawes. I arrange visits for Sherwood Observatory.
Hey, good evening, Joe. I'm Brendan Schooler. I've been a member here for about 12 years, as most of you already know. I'm currently a trustee, oversee the events and the night school for the society, and yeah, that's pretty much me in a nutshell.
Hi Joe, my name's Stephen Smith. I write the look-up article in the EH each month, and I'm one of the editors on the EH, and along I've been a member of the MSAS club.
We were also going to be joined by Emma Taylor, who does our social media, but she's ill tonight, can't make it, so we're going to have to carry on without her, and we'll get her back for a debut another time. So to start with, let's talk about some of our highlights of the year gone. If anyone has anything specific they can think of now, we can get going with it.
Well, go on, Rob. I certainly do. Probably a couple, but I think Rob's keen to go for it.
Okay, yeah. Well, an outstanding highlight for me and other members is when we went to Iceland earlier in the year, February to March. We had a 10-day break specifically to take in the Aurora. And we were very lucky where we did see the Aurora. It's just a highlight.
And when was that?
That was middle of February to early March.
And who went?
There was myself, Brendan Schooler, and
Gary Levers.
I
wish I started it now because he's stealing my thunder.
And you kept all the members well informed with loads of photographs and an account of your experiences.
That's the beauty of social media. Everybody felt like they were there with us.
Yeah, brilliant photos.
I've been thinking about Iceland for a long time over the past few weeks, and I miss the place. And Rob's exactly right. It touched on me so many ways. I mean, the beauty of Iceland, it's raw geological terrain, and the beauty of the night sky is stunning. The Aurora was the first time I've seen it in my life.
Didn't one of Gary's pictures win Picture of the Month of the Aurora?
Yes.
Is that in Iceland?
March.
I believe it did. Well, yeah, it's up there. It's March. You can see that's the time we went. So you can see that there with the log cabin. That's a place in Iceland called Starfaflora. And as you can see, the back of the mountains is the green Aurora. And that is the colour that you can see with the...
Can I ask you a question about the Aurora?
Certainly.
Do you know when you're watching it, is it move as quickly as it appears to do on a film? And does it look quite bright in the sky?
Absolutely, it does. We were very fortunate to have a great display in several places in Iceland. And you're absolutely right, Steve. It does move about and your head's on a swivel. Literally. It is fantastic.
Sounds fantastic.
It is.
What's quite remarkable is that on the 4 different nights we witnessed it, it was just different every time. There was one night where it was very subdued and it kind of like pulsed and it came to and froed in and out the sky. It was like really quite ghostly, like, subtle sort of pales of, creamy, milky colour coming out of the sky, just various patterns just pulsating, coming and going. It was quite surreal, very ghostly and apparition-like.
Was that the first time for all of you ever seeing the Aurora?
For me personally, yes, it was.
No, I've been to Iceland before and seen it before, but it was still a fantastic experience. And there was parts of this Aurora what I've not seen previously. The coloured columns, for example. Yeah, it was just fantastic.
Looking at the picture now, you can see amazing greens. And did you see some pink?
Yeah, there was certainly pink.
It's rarer, isn't it, to see pink?
I believe so. Green is predominantly the colour you see the most. But yeah, I mean, there was one occasion, Gary and I was outside and Rob was inside. I think he was on the telephone to your wife, and all of a sudden it just switched on. If you think of a fluorescent tube, and sometimes, when they have trouble starting up and it kind of flickers, then it just zips to the middle and bang, it's on. Wow. It was like that instantaneous on one point, and yeah, it was me and Gary was just jumping for joy. We were kissing the sky.
Everybody back here was very jealous, looking back.
We were partly there with you.
But we were shouting for Rob to come out, and you did eventually after your phone call, and yeah, it continued all night.
Yeah, it is. We're trying to take as many people with us on this adventure as possible to try and enjoy and encourage people to go and see it themselves.
And of course, we had some amazing footage of Rob's driving skills on the snow. I'll always remember that. Like you were having a lot of fun.
Yeah, that was quite some terrain over there. The back end of winter in Iceland, it was quite challenging in some circumstances. 5-6 foot in places, but that 4x4 duster certainly got through it.
Thoroughly recommend Dacia Duster 4x4. Way to go. Never let us down once. And we we went into some real challenging conditions, and like I say, it got us through.
4-wheel drive, first gear. How many rev counts?
Did you manage to get any sleep on that trip?
The person who slept the most was the one who was in the back. The front two, one navigating and one driving, not so much sleep.
Did you slightly point to Brendan then when you said the man in the back?
No, we took it in terms of driving. There's Rob being theatrical with the arms.
I do like moving about and pointing and stuff like that.
No, the man in the back.
No, to be fair, we had an equal share of driving around Iceland. That was a great experience in itself. I mean, Dacia Duster, as Rob said, we had studded tyres to go around, as you need to in Iceland at that time. Certainly great grip on the road.
And we experienced all conditions from clear blue skies to horizontal snow and sleet and howling gales. It was just absolutely stunning. A great experience.
But yeah, keeping it true to astronomy though. Aurora, absolutely stunning. First time I've seen it in my life, and the night sky, pitch black, no street light interference at all. It was great.
Perfect.
It was just like, it was really quite eerie at one point. You just see them caught out the sky and disappear again.
Well, it was. It just nothing there. Then all of a sudden, catch on.
You always kind of hoped for some hell to break loose and you would get a big flash of green light or something, but just one night it just stayed like that.
Yeah.
The next night it just went mental.
Yeah, like I say, I think the second place we were staying, we had the curtain effect and stuff like that.
Yeah.
I do like those.
We all like curtains.
Yeah. Those fluorescent tube things, they're good, but I like the curtains, the swirly curtains. You can see the magnetic field lines and stuff. They're really good. And that looked good because it's in that cabin in the woods as well. That just gave it that little edge on that. Like I say, the last place we went was stunning.
Oh, the cabin with the tree line, and you've got the Aurora dancing between the trees.
Yeah.
Kirkby Klaus, I think it was. Yeah, beautiful.
It was just often look back on the pictures and perfect.
In fact, that was the night where I think we gave up and we went to bed. And I kept looking through the window in anticipation of something happening. And was it kicking off? And I went outside, barely any clothes on. Seriously, I had my pants on, I had no socks on. It was freezing cold. There was ice on the floor, there was snow everywhere. It's like, Gary, get up! It's like, Rob, you need to see this.
Yeah, that's how it gets you. You know, you just want to see it just because it can come and go very quickly.
Yeah,
it just can. You know, it could be there for I don't know, an hour or more. Then it might be 5 minutes. You know, you got to crack on and get up there and look. You know, it's cold. You ain't got much clothes on, but get out there. But it's the beauty of astronomy. It's just I just like the natural feel of it as well, where you are in the countryside and just a natural phenomenon happening. It just does it for me. Just does. Simple as.
Sounds eerie as well.
Yeah, it's all that Stephen Moore on it. I'll be going back again without fail. It just
sounds a bit like an eclipse, experience.
Yeah. You're right.
It was an easy watch in Iceland, even though it was cold. It weren't that bad. It was bearable if you got the gear. And we weren't all outside naked. We did go back inside and pick up and come back out with the cameras and that.
Yeah.
But I felt more reassuring in Iceland that there's just nothing there to come and bite you on the arse like a big brown bear that you'd find in America or something like that. That's a fear I had in America doing stargazing at night time, that something would just creep up on you. You would hear cooings and noises in the woods, but in Iceland I just felt perfectly safe.
Oh that's right.
Steve, the last year.
I forgot all about last year.
It's on to next year now.
Yeah, last year.
What are your highlights from last year? This year, the last year just gone.
I've thought about this because you mentioned it the other day, and for me, it was, we've been looking for several years towards the Webb Space Telescope going up and hopefully working and hopefully sending us back some new information. I can remember when the Hubble went up. It didn't work properly. It was a mess. They had to fix it, and then we started getting some fantastic images, stuff we've never even imagined, like the deep field where we've got hundreds of galaxies in a part of space where there's nothing there. Now, we've been looking forward to the Webb going up, and last Christmas up it went, And then there was a process of it getting itself commissioned, ready for sending photos back. And I think it was in June or July when we started getting the first images back. And wow, those images are just absolutely stunning. And the promise of it all is that we're going to be seeing new stuff. I mean, I, like a lot of astronomers and scientists, thought that the Webb images would be infrared or in a different colours to the known spectrum that we use as human beings. So we didn't think we'd get the clarity on them, but they are just phenomenal, and people are worrying over them. But also the science behind it. We may be able to detect atmospheres on planets and stuff like this. So for me, the highlight has been the Webb going up there, deploying safely and sending stuff back. And it's the promise of stuff that's going to come over the next 10 years or so before it runs out of juice.
Do you have or does anyone have a favourite from an image that's been released so far from James Webb?
Yeah, I think it's the Stephan's Quintet. We are familiar with the galaxies. It's a close bunch of galaxies and one that's set aside from it, but it looks like it's in the field of view. But the interaction that's happening between four other galaxies is just mind-blowingly more clear with the Webb photograph. The details are there. So that one for me just was a wow.
And one of the five is essentially photobombing the other four, isn't it? In that picture.
Yeah, it's just lined up with it basically. Yeah.
But it makes a very good picture, and it's really good.
It's just amazing, like I say, Steve, when it's imaging, say, Jupiter, and the amount of galaxies it's picking up in the background is almost like an afterthought.
Yeah,
it is. And it's only really sort of testing its instruments out and stuff like that. So it really gets down to the serious business end.
It's amazing that they're finding discoveries in pictures where they're not even aiming to discover those things. They're taking a picture of something, and in the background there's dozens of other things to look at.
I do like where they're comparing the Hubble infrared to the Webb, and just seeing how much is the improvement on it. And it's just incredible. Some of the images from the Orion Nebula as well, where they're comparing and see the star formation and planetary disks around newborn stars. It's just
everything about it is just wow.
It is.
It's like you were talking, we were talking about the Hubble Deep Sky photograph, where there's hundreds of galaxies. That was took over a huge amount of time. It took a couple of years. Every time the Hubble swung round, it spent hours on that deep sky image, and accumulated in that photograph. But the James Webb looked at that area for 12 hours and came back with fantastic images, and we're seeing further back, basically in time, and there's bits in there and detail in there that we couldn't see with the Hubble. It's just fantastic.
That image started discussion on the earliest galaxies. I think the timeline they're thinking of now might be slightly different to what they thought beforehand. So it wasn't just a shot to look good. That one, it's come up with some decent science.
Yeah.
And I say, Hubble has given lots of scientists problems to sort out and solve, and Webb's come along now and sort of piled everything on top. It's just a golden age. Can't wait for Carl Sagan's scope to go up.
I heard about that the other day as well.
Yeah. I always think the James Webb is like the Hubble Space Telescope but on steroids. What it's delivering is absolutely stunning. It really is. It's truly remarkable.
And it's working.
Yes. There were so many components that needed to come together to work.
It is. That was the big thing, wasn't it?
Yeah.
During that flight up to the Lagrange point 2, just one of those things not working right. The sunshade not unfurling and stuff, and it would have been game over.
Even being hit by a meteorite and stuff.
That's the trouble. When you look into those images by the JWST, you see these little red fuzzy blobs that's so distant away. You just want to know more about them. Then you begin to realise what is the limit of the capability of the JWST, really, because, it's those sort of entities out there that are going to reveal the deep, dark secrets of the early universe, really.
Do you have a favourite picture?
There's so many that's been bandied around, but I'm a big favourite one of mine is the Pillars of Creation. I know it's like an old cliche, but like Rob was saying, the comparisons between the Hubble Space Telescope and the JWST. And on a lot of news channels, you can get a slider that goes across from one to the other and see the comparison. And that's quite a useful tool just to compare and contrast, really.
It's like going from your cathode ray TV to your
to a 4K. Yeah, to a 4K brand new.
The good thing is as well is the scope can see through dust and clouds, so we can see in the pillars of creation, we can see the stars in it, whereas the Hubble can't because of dust.
In it and beyond it.
Yeah.
Yeah.
It is. I was using Hubble and Webb images as a comparison the other week, and it's just like, really? I thought, Hubble, brilliant, but it's just crazy.
So there's a big promise there, isn't there, of what's to come. Yeah. You know, if we can tease out a lot more detail, who knows what we're going to find.
Well, the good thing is, fortunately, Webb has all worked. That technology, the movements and stuff like that, they've sussed it. So like I say, now it's a Carl Sagan replacement for Hubble in the optical.
Yeah.
Can't wait for that one.
It's a similar design, isn't it? But just more.
Bigger. More. More.
More power.
And you mentioned, Rob, about background galaxies, like when you're looking at Jupiter and Neptune and stuff.
Yeah.
In the same shot is you see galaxies and you're looking as much at the background noise, the fuzzy bits, as well as the main object on display. Brilliant.
It is. It's just incredible what they've achieved on it. A long time in getting there, but boy, did they get there. Yeah, so fantastic.
Well, has anyone else got anything else from the previous year to talk about?
If there's anything that springs to mind, I was pretty excited by the extension to the Juno mission. So those who don't know, the Juno space probe that I think set off 2011 from Cape Canaveral. I think it went up on a Delta V rocket. So it spent 5 years going to Jupiter to actually look into the depths of the Jovian system, really, to understand it better. And oh boy, it's brought about some new science and understanding about the big gas giant. But its current mission has been extended, and it's really looking into the Jovian satellites, so the Galileans. So there's been some exciting data that's come out of that recently as well. So yeah.
How much longer has it been given? Because it's not the first time it's been extended, is it?
Timeline-wise, I'm uncertain, but it came into operation around Jupiter about 2016, and it's just recently it started on the Galilean satellite, so I think 2021. It's had a close approach to Geminid, and I think September this year, about September the 29th, we had a close approach to Europa, which was quite stunning. If you see those images of Europa up in close detail, I mean, it's travelling past at a phenomenal rate. I think something like 15 miles per second, and it captured a really good close-up image of Europa. I mean, if you look at the images, something like 93 miles by 125, it really is a zoomed-in sort of like snapshot of the European surface. But yeah, truly stunning, and that's the latest thing that got me excited. And
isn't it destined to plummet into one of the moons when it finishes?
I think into Jupiter at the end of life.
Is it?
Yeah.
Well, they usually aim for Jupiter, don't they? Because nothing will be tainted.
Yeah, but what will be exciting is next year. I think next year, onto 2024, they're going to take the Juno spacecraft and actually put it in orbit, more akin to where Io is. So hopefully we'll get some good surface images of Io. As you know, Io is a highly volcanic moon in the solar system. In fact, I think the most volcanic body in the solar system.
It is indeed the most volcanic activity.
I think when you look at it, it just looks like a bubbling sort of margarita pizza that's come out of the oven, because it's just, splattering, tomatoes.
Very sulphurous, doesn't it?
Yeah, that would be stunning. If you think of close-up images of Io by the Juno spacecraft, then that would be great. So that's to come next year, I believe.
You can never learn your way around Io because it's changed the next day.
Well, that's it. Yeah, its surface is molten. It's gravitationally interlocked with Jupiter. The gravitational pull of Jupiter is actually, compressing and twisting Io, gravitationally, and it's creating a lot of frictional forces that heat up, and it's making Io a hot body to deal with, really.
Excellent. Well, my favourite thing from the last year is the image of Sagittarius A star that came out, the black hole image at the centre of our galaxy. In 2019 they did an image, don't they, of M87, and that was released to the world to astonishment. I think that came massive, out without us really thinking about it. It's 1,500 times larger than the black hole at the centre of our galaxy, and the picture we got was just epic. It was 8 telescopes around the globe with the Event Horizon telescope with interferometry, creating this image. I think it was 5 days worth of collecting data and 5 years after that getting the image ready to be released this year. Yeah, it's just amazing that they got it.
It is an amazing thing, yeah.
I think it pretty much resembles theoretical prediction, really, which is quite remarkable.
Einstein proved right once again, and it looks gorgeous. The rings around this silhouette of just emptiness. Yeah, I really enjoyed seeing it, and I didn't expect the one in 2019. I didn't know this one was coming, to be honest. I don't know if anyone else knew it was coming, but it popped out, and yeah, I thought it was amazing ingenuity that comes around to bring that kind of image.
It is. In the last few years, isn't it? We'll look, gravitational waves being detected, for example. The technology, what's being used, is absolutely cutting edge, isn't it? To achieve these results. It's just, we're living, like I say, golden age we're living in.
You're talking about gravitational wave detectors, LIGO, and there's another one, I believe. Obviously, the next step, they're wanting to put some in space, and whether they be even further apart and more accurate.
Yes.
And
I believe that's called the LISA mission.
It is indeed.
More than just neutron
Yes.
stars and black holes merging, they'll be
Yeah.
able to see a lot more things. Because I know somebody demonstrated that we're all creating gravity waves, with our little small masses. And so it would be interesting to see what resolution can get down to and what they can see with space ones.
Absolutely.
Yeah.
It's the distance they want, isn't it, for the better measurement, to have the two instruments further apart. So
Yeah,
going to space makes a lot of sense.
Yeah.
Yeah,
It's amazing technology.
Yeah, but they've tested the technology. It's just a matter of getting the funding and stuff like that, isn't it?
Mm. And they did compare in one of the Astronomy Now magazines, I think it was 2 months ago, the size of Sagittarius A, black hole, compared it to the orbit of Mercury, I think it was.
Yes.
Right. And then they showed the M80, which one was it?
M87.
M87. Right. And the M87's black hole was far bigger, I think, than the Pluto orbit and the Sun.
Yeah, it is. The solar system looks very small in picture comparison compared to M87. It's a lot.
Okay.
A lot of space taken up with that. I think that's one of the reasons the picture of our own black hole was harder to get, because it's obviously a lot closer. But even at that closer distance, it's so much smaller, and it's obscured by everything looking through the galaxy. It's 3 more years, I think, to work that image out.
Yeah.
Pick the detail out from all the noise.
It's a remarkable feat just to get the angular resolution on the night sky to get that in M87. Yeah. Stunning.
Yeah. Well, if you're looking, they do a video simulation showing zooming in on Sagittarius A star, and they kind of show the gas they've had to look through and all the things in the way. So it really is amazing how they pick that detail out.
I think it's incredible as well when they're talking about the black hole in the centre of our galaxy, when they're showing you stars slowly approaching it, speeding up, then just skimming it and shooting back off again and coming in from different directions. They appear to be elliptically orbiting nothing there at all because you can't see it. Yeah. So but the fact that they have been tracking these stars and they can see stuff. It's not very active. There's not much gas falling onto it. It's very, very infrequent. So there's very little happening. But there's some, obviously, galaxies where it's very active. We're luckily not got that. So
ours isn't giving off much energy, really, at all, is it?
No.
It's just ionising just enough gas for us to stare at it from a long way away.
Want to be a long way away from one of those.
Yes.
Close enough, pal.
Oh, thank you, Joe. That was very interesting, that one.
That's right. Has anyone else got anything exciting from the past, or should we move on to the future? I know we're all desperate to talk about Brian Cox's show, and some of us getting an executive box, because that was a highlight for me and some other people this year.
From a distance very far away, I believe.
It was, yeah. To be honest, it was. He was very small on stage, yeah. But that was volunteering in the lobby.
Well, it was
the
fun
most
seeing
point of
so many members down there as well, helping out, promoting the society, and it was really nice actually getting to see someone like Brian Cox,
Yeah.
who you'd only see on television.
It was a nice MSAS trip out, to be honest. There
It
were
was.
so many of us there. I don't know how many, if anyone knows how many of us there were in the end.
Oh, I
There
think it
was
was easily,
15 or 20, aren't
yeah,
there?
Yeah.
easily into double figures. Yeah.
And we got really good response from the public talking to us in the lobby
Yes, we did.
about the planetarium project coming up and about the telescope here. So many people from actually not far away who'd already heard of the society. And I don't know if any of them have come here since, but they all seemed like they wanted to.
Well, they certainly got a leaflet thrust in the hands.
They did, yeah.
And they, in that short space of time where we had hold of them,
Yeah.
they learnt an awful lot about us. And it's surprising with how many people haven't heard about us. So there's still a lot of work to do out there, without doubt. But it's good with these big missions like the Webb, for example, Juno, Artemis 1 going up. It gets in the public mind, so they start thinking space related, which can only be a good thing. So much stuff going off to literally suit everybody, whether it's flying to the moon or exploring distant galaxies or the solar system. It is. There's something for everybody.
I mean, Artemis 1 has just gone up a few days ago, hasn't it?
Yeah.
So there's not much for us to say on it apart from it's at the moon now, isn't it, Steve? Did you say?
It's just coming round the back of the moon and coming out again now. Its booster rockets should have fired, and it should be accelerating. Well, should have been accelerated to take its path back to us. So it approached the other side of the moon, about 80 miles away from the moon at that point. So that was its closest point, but obviously it's in a radio blackout area. So its jets should have fired round the back, and then the engineers would find out when it appears back in view from the Earth. And also it sent some photos back of the Earth from that position. So we've got the blue dot, basically, enlarged blue dot.
HD blue dot.
Yeah, absolutely. So, which is always lovely to see.
It is. Surely when they do land on the moon again, there's not going to be any radio blackout. Sure, they're going to have satellites to relay communications. Surely.
Well, they normally have an orbiting spacecraft that does that job.
Yeah.
So
I'm not really clear on that, because I think the mission at the moment, they anticipated a 30-minute or so blackout going around the back of the moon, so there's nothing in place as we speak for that.
no,
They're hoping to put a
Strange.
gateway up at some point, aren't they? So whether that'll have a relay on it.
it would have
I
been
don't
a
know, but
bit.
I don't know when they're planning to put that up there.
Would have been interesting if it didn't reappear again.
Well, there you go.
Or
It's
appears
12:01.
somewhere else.
Yeah.
Comes out from around the back of Mars.
I always feel like there's some kind of anticipation or fear that something untoward's going to happen on the far side of the moon, because we can't see, or communication is cut and devoid. It's
The
like
whole
the fear
civilization,
sets in. It's just like, just by orbital mechanics, it's literally just going to come round anyway. So I mean, what state do you think it's going to be?
Do you think the fear comes from the fact that the burn has to be on the other side of the moon, and we don't know if it's worked until it's come back
Quite
out the other
possibly.
side at the right
I think-
time? There's
I
always
think
that anticipation.
Sorry. I think if you're a lunar and you're going round the back of the moon, like Collins did when, we first landed on the moon, and you're going into that blackout area, you must feel like your tether with Earth has been cut. And so it must be a relief to finally re-establish contact with your fellow beings.
The loneliest
You know,
person. Yeah.
Exactly.
Loneliest person, the loneliest humanoid.
You might have
At
just been
that
glad
time.
to get away from it for a bit.
Well, I think that's what he said, isn't it? He wasn't bored or anything like that.
I think eventually he got the chance to walk on the moon, and he did go on to the moon, didn't he, Colin?
I think he was offered, wasn't it? A
Yeah.
chance to fly and land on the moon.
But this is all good stuff. But what also happened back then, the public, once they'd been on the moon the first time, the second time, the third time, interest waned. Oh, the men on the moon still. No, I'm interested. They've done that last time, didn't they? So the public's interest does tend to wane. So it's nice to have these grabbing events, you know. But the interest tends to dwindle if they see it too often. It's like any news report. It's got a life, and then that shelf life runs out.
Be interesting to see how this plays out in capturing the national, global interest. It will be, what the response is. Yeah, whether nations give two hoots whether Americans have gone there again or not.
It's all, obviously, I think Neil's here as well tonight. I'm sure he might know something about it. But it's all a step in the right direction for going to Mars, obviously. And that's what I think it's all about. It's not because it was a political race back then to get to the moon, first people on the moon, more than anything else. Now it's about getting to Mars.
It's a logical stepping stone, that's for sure.
It is, and it's good. I think I'm all for it.
I think in a way it feels competitive again, though, still, with other countries putting their mark on space. It's like a space race again, but not on the massive rush that was there in the 60s, I think.
Yeah.
Well, the first lunar landing, the talk was the logical step is the moon now, Mars later, and it all fizzled out. So, but I think they've got to do that. Like I say, the moon would be a fantastic proving ground for all that technology on it. And the time they've been in low Earth orbit on the International Space Station, testing various equipment packages out, all ready for this. It's a logical step.
It is, but I still think Mars is such a long way off. It could be the equal time frame as it has been from the 60s, 70s to get to Mars as it is now, really. I really do think the amount of effort and time and technology and resources and financial money to go into missions like going to the moon back in the day and even now, if you think about how much that would take to get to Mars.
The journey
it's a different
to Mars.
ball game altogether.
How do you survive that long on the journey there?
Distance is a problem. It really is.
It is a problem.
6 months, isn't it?
And you've got to keep people alive all the way there, while you're there, and presumably if they're coming back.
Oh, absolutely. What are you going to do? You're going to go to Mars, going to stop for a fortnight, quick look round and pop back home?
Well, they did when they went to the moon. They stopped a matter of hours, really.
Yeah.
So, but I think Mars will have to be supported by other vessels that's either in space, or they're going to have to send bases and be ready for humans to go there. And then it raises all sorts of
to plan to go to Mars, you'd be taking technology that can actually utilise the processing of Martian regolith into useful products and materials and building materials, I think.
It is like that MOXIE instrument on Perseverance. It's proven that it's produced enough oxygen like a small tree. Yeah. So that technology works.
And that's only the size of a shoebox.
Yeah.
So
absolutely.
Who knows? Should we talk about the year coming?
Yeah, certainly.
And both at the observatory and in astronomy.
Well, that's common to us all, really, at the observatory, because we're going to hit up on the construction phase of the Science Discovery Centre and Planetarium, and that is a major milestone in this society.
And what month are we aiming for that?
That's an interesting question. It's Rob, do you recall back end of the 2023? I would have thought.
Yes.
Post summer, I would have thought maybe. I might be wrong. Project manager Steve would know better, but it's been a moving beast slightly, to be honest with you, on the months.
The planning application's already gone in, so that's one big step. So we need to see what the council comes back with on that. But probably back end of next summer, that sort of thing, construction to start.
So that's probably the biggest news for us as a society is we're going to start building work on our own planetarium next door.
Yeah, I think it's going to be a pinch of skin moment because it really is.
Is this really happening?
Yeah.
Well, there's some great work what's already been done. The pump house being almost demolished and taken down, recycled, that sort of thing, being made safe, where the pipe work was, that sort of thing. So that saved the society quite a lot of money. And again, it's a good thing for the membership to get involved, which I think that's a good selling point for the membership, where they can make an effort and be involved in the process of conversion.
Well, I think it's a great point from the last year and the year coming. The members' involvement in, well, let's face it, saving the society, is it tens of thousands?
Sure.
In taking down the old pump house on top of the reservoir as a team. and not only that, people have spent a lot of time cleaning off bricks so that we can sell the bricks and actually make some money to go towards the society doing it.
They're going to be recycled, which is a great thing. The Victorian Reservoir will live on in different guises. Oh, it's great. I'm quite happy with that.
So we've got the planetarium. Anything else for anyone?
Well, speaking of the MSAS Society, for me, I was quite interested to learn that we're going to have new glass in our big scope upstairs. And they're going to Orion Optics, and Orion Optics are going to create a new primary mirror. It may be fractionally smaller than the 24-inch we've got, but it'll be Hilux coated, which gives off something like 98-99% reflectivity. So that's going to be great. We're having a new secondary mirror, of course, and we're having a new mirror support system, which I call a whiffle tree. That's what a lot of people tend to call it. The support system for the primary mirror. So this new glass is going to change the view from that scope upstairs tremendously. I'm really looking forward to it. We'll have the light grasp. We'll have optics in which are really of a high class. So I'm looking forward to looking through the eyepiece, using the new glass, hopefully by some point next year. So that's what I'm looking forward to.
So in terms of the new glass and improvement, is that going to be a picture with more clarity, more definition, or a better? I know it's not going to increase magnification.
Yeah, the existing mirror is not quite figured correctly. There's some aberration there. It's extremely difficult to collimate it so that all your mirrors are lined up properly with the eyepiece without some distortion coming from some part of the primary mirror. That's my belief anyway. The new glass is going to be of a higher grade. So we talk about waves and stuff like that. There's many measurements that can be taken into account, but there's various grades of mirror. There's like science grade, isn't there? There's high grades, there's mediocre. It all depends on the wave of the mirror and other polishing techniques and the coatings as well. So it's quite complicated. But the company that's doing it, Orion Optics, they've been doing this for a number of years now, and they are quite a popular brand. They make a popular brand of telescope for the public, and they undertake resilvering existing mirrors up to a limit of 24-inch. Our mirror's 24-inch, and I think they couldn't make a 24-inch for us, my understanding. I think it's going to be something like 23 inches and a bit with slightly turned down edge, but it's going to be of a high grade. So basically all the light that's going to be hitting it is going to be bouncing up onto the secondary mirror and out through the eyepiece, and it should all be relatively in line, and a lot of that light, there should be more light coming through because of the coatings and because of the light that's hitting that mirror is coming back rather than being scattered elsewhere. So, I mean, no mirror is perfect, but I think a 24-inch or 23-inch with Hilux coatings, a new mirror from them is going to make a big difference.
It's going to look brilliant, I think.
Yeah, I'm sure it is.
I don't know when it's being fitted, but I do remember from the founders' interview we did, that I did with Rob, their first thing they looked at through there, I believe, I don't know if you remember this as well, was the Orion Nebula. So I don't know when the mirror is coming, but we could have that as our first target again if it's the right time of year.
Right. I don't think it will be, because we've got the season now where we're tending to use the scope because of the dark nights. So if we get the mirrors next week, I don't think they'll be fitted
is it that soon?
Until the lighter nights. It'll going to be after Easter, I'd say. So I don't think
that does make sense.
But we can
It'll
look
be a
forward to
springtime
that.
installation, basically.
Yeah,
Pardon?
It'll be a springtime installation. I would have thought.
Exactly.
Okay.
Yeah.
So, yeah.
Well, it was a nice thought.
No, it's fair comment.
I mean, to be fair, with the scope we've got upstairs, I mean, it does offer some good views. And when you look at the Orion Nebula on a good night upstairs, the actual optical diameter of the mirror, the 24 inches, comes into itself, really. The resolution, you know, when you look at the Trapezium cluster in the centre of the Orion Nebula, it's well resolved. It's really good. And it's significantly more than what I've seen through my 5-inch refractor. And that just goes down to the size of the mirror we've got. So it wins hands down in that regard, and like you say, Steve, it's going to bring a lot of optical clarity to our vision, which I'm really looking forward to myself, really. So yes, it should be easy to collimate, that's for sure. Well, I'm hopeful it will be, touch wood.
Yeah.
Yeah.
So I'm looking forward to that.
Yeah, good.
New glass.
Excellent. Does anyone else want to jump in with anything for what they're looking forward to next year?
Well, it'd be nice if the meteor detection beacon really comes on strong.
Yeah.
Now we've got it. It'd be great to integrate that more with the society and see where that leads for publicity as well for the society.
Yeah.
Once that really kicks in and people get used to it, you know, being located here.
Yeah.
So
I've got something for next year that is happening, and it's a NASA mission that I'm not involved with. That sounded like I was involved with it, then I'm not.
Oh.
It's the Psyche mission, and
You could be, Joe, if you do an Obscast with them.
yeah, well, yeah,
Live.
I'll get in touch.
Live, yes, yeah.
Yeah, this is the Psyche mission, and Psyche is an asteroid orbits between Mars and Jupiter with the rest of the asteroid belt. But this one is a bit different, and I hadn't heard much about this mission, actually, to be honest. And this asteroid seems to have exposed metals, meaning it's very metal-rich, and maybe the remnant of a forming planet's core. It's a body that started to mould its mass into a planet for long enough that the metals, mostly iron, settled down into the core. And then a collision of some sort stripped off the outer rocky surface, leaving only this planet's core to cool down quickly. And it's scheduled for October to launch, 2023. And it's really the only chance we have of exploring a planetary core similar to the one at Earth, because obviously planetary cores are usually quite deep down and very hot. So it's if we want to study the early formation of our solar system, some 4 billion odd years ago, this is the chance we have, really, at looking at how an early protoplanet, I think they're called, would have formed.
Sure, these missions are fantastic. We can look back at the very early beginnings of the material that went to make the solar system, a bit like Comet 67P.
Yeah.
You know, when what ESA did with that, orbiting that ancient wanderer and then actually landing on the surface. So if you see some of the images when it's what they've taken of it, it looks like an alien world, not an old lump of rock and ice. And that is absolutely stunning. We need to explore more of these and, you know, find out exactly how they formed. Because I think that looks like it's just two ancient lumps what have had a slow impact together, where it's got that wasted neck on it. But stuff like that, a bit like the Japanese Ryugu mission as well, bringing that material back. All stuff like that is fantastic to see how the primitive material was what went to make our solar system. It's really interesting.
And it really is yeah, like you say, it really is the history of the solar system, and it teaches us not just about our solar system but other ones.
Yeah, absolutely. You know, unchanged for billions of years. We need to get one of these asteroids and park it in Earth orbit.
Yeah.
We do, so we can really and tether it to the International Space Station. Now that would be fantastic, wouldn't it?
That's what I'm looking forward to next year now, is you coming up with a mission to go and fetch.
Can you imagine, got one of these, just a small lump of rock, ancient lump of rock, tied the bloody thing to the ISS.
Yeah.
The study that would do, the interest that would create. Come on, that's the way to go. You need to get out there and do it.
This mission is not landing on the asteroid, by the way. It's a flyby, this one, but it's using a spectrometer to analyse the composition of the asteroid and a magnetometer to
bring it back.
Yeah, the magnet to bring it back for Rob. the magnetometer to measure any magnetic field that may be left.
Well, it is that you go to these missions and they back fantastic images, bring up a few fragments of the material. But for me, I just want to know more.
Yeah.
Bring the whole lot back.
Yeah.
Just do.
Would that not
land on it.
disturb the orbit of a lot of the solar system if we brought that much mass back?
It's just fantastic what we can do, these robotic missions. And they can land on these objects, bring some material and come back to Earth, send it back to Earth. Brilliant.
It is fascinating what they can
It
do.
is. Still rather have a human there with a shovel, filling this sack up and bringing that back.
I don't know if you get through Psyche asteroid with a shovel. You'd need to get through iron. If it is iron, we don't know completely yet. We'll find out.
We'll find out.
Right. Should we take a short break and then pop back for Steve to tell us all about what's going to happen in December in the night sky for us to have a look
It's
at?
going to rain. It's going to be cloudy.
Well, then we can have a short break and Steve can come and tell us what we would be able to see under different conditions.
Are you saying we're going to miss the Mars opposition in December?
Yes, we are. A bit like Jupiter and Saturn,
I
wasn't
missed
it?
my
That
chance last night.
closest approaching its cloud.
Okay.
Yeah. Right. We'll be back momentarily.
Who's making the tea?
Right, we're back, and Steve is going to tell us what objects are going to be behind the clouds this month, apparently. So you can look up and imagine what you would be seeing if they weren't there. Right, Steve, what have you got for us?
Oh, right. Okay. So, well, basically, we're heading into December now, so we are getting roughly 12 hours of darkness. So we should theoretically get more opportunities to enjoy the evenings looking out up in the sky. In the summer, you have to wait until probably midnight, but now is the opportunity. But it's going to be cold. Okay, so what are December's highlights? For me, at last, Mars comes to opposition on the 8th of December, but it's up there now, and it's there for us to enjoy for the next 6 or 7 weeks. And obviously, Mars coming to opposition means it's going to be at its closest to us. So we should it should present itself as a bigger disk than what it would do a year ago, because it takes 2 years and 2 months to line up with us properly and be at its closest. So this is your chance to see Mars. Interestingly, it comes to opposition on the 8th of December, and it's also occulted by the moon on the 8th in the early hours of the morning, probably about 5 o'clock. So the moon is going to occult Mars, which is interesting. So for me, I'm looking forward to studying Mars, seeing all the different lights and darks on its surface and trying to identify certain parts of Mars. And I hope you get the chance to see it too. Okay, well, Jupiter is also up there, and it's a blazing sight all month. And there's loads of stuff up there. This is the Perseus, Cassiopeia, Orion, Aurora, and Taurus. They're just bursting with interesting objects. So my look up article will be in the EH, and in there will be more details than we're going to talk about tonight. But I'm just going to give you a few tasters. The annual Geminid meteor shower peaks over the nights of the 13th and 14th and the 14th and 15th of December. And it is possible that 140 to 150 metres an hour may be seen. It's quite likely you'll only see about 50 if it's really good too. This year's peak coincides with a gibbous moon, which will drown out a few of the fainter ones. It's a good idea to roughly chart any meteors you see. If you do get comfortable outside and you're going to do some meteor watching, then get wrapped up warm, get comfortable, and stare at the area of the sky above and around the area of the radiant. But I have a sheet of paper normally as well, and I class the meteors as a 1 to 6 according to the brightness, and I'll put a little picture of Gemini in the middle of the page. There's just a blank page, and then I'll draw each meteor as I see them as a 1 to 6, 1 being the brightest. I make the line long and bold or a 1 if it's short and fainter. So if it's short and faint, and it's a 6, it's a short and faint line, etc. And then at the end of the night, you can count the lines up, see how many you've seen, and see if they emanated from the radiant. So that is the Gemini. It's one of the best showers of the year.
Yeah. We've been lucky with them lately falling on weekends, meteor showers. This one's on weeknights, I think.
Yeah, it seems like every month we've had meteor showers. I mean, there's 2 or 3 last month, and but nothing really happened. You know, the weather is a big deterrent. So if we do get clear nights, then despite the moon, this is a really good one to watch. Have you bothered to try and see the Geminids before, chaps?
Not in recent years. Many years ago, I would have been more proactive in that, and I have seen them before. Yeah, I've always been on the lookout for the Perseus, largely because August is summertime and it's warmer weather and it's more comfortable to do, really.
Yeah.
My meteor viewing comes if a child wakes up in the middle of the night, to be honest, and then they go back to sleep and I'm wide awake. So I think
you're looking up at
go
that
and have a look.
Always looking up.
Yeah.
I always find them hampered by conditions. There's always a pesky full moon close by, or the radiant is rising at an appropriate time or something like that.
Occasionally, you'll see a really bright one or a bolide or something like that, and that creates a wow, and then it makes you exclaim out loud. So, but this is also something you can do without any optical equipment. You can do it with your family. I've been outside with my children as they were growing up, and grandkids as well.
Yeah.
And just to sit there chatting away, looking up at the sky, and it's very difficult to miss the brightest meteors. So it's a wow moment, and I enjoy it, you know. But you've got to be warm, to get warm as well.
We had that last year for Perseus, I believe, didn't we, up at Magpie Mine?
Yeah, we did. A few of us went up to Magpie Mine, and we had a really great night up there. It was mild. We had deck chairs out. We had a picnic blanket on the go. It was just a stunning, lovely night, wasn't it?
Beautiful.
And for the first time in many years, we had an absent moon, which made it all the better.
Okay. Another delight for me at this time of year is the fact that Orion swings into view at a reasonable hour. I can remember looking up in the sky a month ago, and Orion was up there about 3 o'clock in the morning, straight up, and very nice too. Oh,
I think there might be some work going on, but this is a working observatory, so we'll deal with it.
Okay, a month ago it was up there about 3 o'clock in the morning.
Yeah.
Now I went out last night, 11 o'clock, and Orion is swinging into view very nicely. Another hour or so. In December, it's going to be in prime position, and there's lots of things to see in there. One of the main attractions, which we're all aware of, is what we call M42, which is the Great Orion Nebula, and we call it M42 because it's number 42 on Messi's list. That's always a favourite. It's always nice to have a look at it, and also within M42. Within the nebula itself, we were talking earlier, Brendan mentioned the Trapezium, and that's a tight grouping of 4 quite bright stars, but very difficult to photograph because the nebulosity of M42 is difficult to capture with the brightness of the stars. So you either fail to see the nebulosity or you drown out the stars because you're taking too long an exposure photographically. But visually, it's quite easy to see the nebula, and it's also nice to see the 4 trapezium stars. And it's a good test of you and your equipment and the seeing conditions on the night to see the trapezium. Right, well, just carrying on this conversation about the M42, I'd like to just go a little bit deeper than that.
I tell you what whets my appetite before I see M42 in the sky. Yeah. What teases me at this time of year is the rising of the Pleiades, the Seven Sisters in the east. Yeah. I find that just whets the appetite for Orion. You know, I love Orion constellation, but when I see the faint fuzzy stars that are just shimmering in the east, rising, is the Seven Sisters. Yeah, that excites me. That's a taste of winter and Orion to come.
Yeah, a messenger on its way.
It is. Yeah,
absolutely.
It's a sign of great things to come.
Yeah.
Do you agree?
Yeah.
Did you get that feeling as well?
Oh yeah. What I was trying to say before was the trapezium, which went out of my head just like that. The trapezium, those 4 stars, which are iconic to the M42. If you can magnify that, get closer down, drill down into those 4 trapezium stars with the right optical equipment and the right seeing conditions, you can pick out 2 other stars. The Trapezium system consists of about 15 stars, but the Trapezium itself is the 4 main stars: Trap A, Trap B, Trap C, and Trap D. If you can drill down further by magnifying that, you can get a glimpse of 2 other stars, which is a good test for optical instruments and for yourself. Trap E and Trap F. And it's something I love to do. I love looking at the Orion Nebula. I return to it every year. We've seen it hundreds of times, but I love looking at it, the nebulosity of it and everything else. The Trapezium 4 stars, but then once I've had a good look at it, I like to drill down into the trap and try and see E and F. Now, in the EH this month, in my looking up article, there is a diagram showing you where E and F is. But when I first looked for them and found them, I tried not to look where they were, but look for the pinpoints of light. They are actually 10th magnitude stars. But if you can see them and then look on a chart, either the chart I've given you or on an app, and see if that relates to your mind, because your mind, your eye and your mind together sometimes makes it up. So for me, if you can find them, then you'll return to them, because it's just a great thing to see, like a lot of other things when we look at the sky. Okay, so that is fairly easy to lock onto. You can see M42 naked eye. It's right in the sword handle or underneath Orion's belt. To use a telescope, you will see a lot more detail, and it's fantastic. So it's easy to find. You can drill down. That's all easy. So I'm going to try and tell you something that's gone into this month's magazine. I read about it in the Astronomy Now, this month's edition. So I've put this article in, and it's about an Able cluster. So this one is a Deep Sky Challenge, and it's the famous Perseus Galaxy Cluster ACO or Abel 426. This is the best galaxy cluster available to us in the Northern Hemisphere at this time of year, and it's available to us all through December. Now, this galaxy cluster, it consists of about 200 galaxies, and it's in Perseus. So it's about 3 degrees slightly north of Algol, which is a well-known star in there. I wrote about Algol last month, and it's a variable star because of it's a binary system and they're eclipsing each other. But 3 degrees from there, there's a whole host of galaxies. And if you stick your scope into that view, there is the brightest elliptical galaxy is NGC 1275. Like I say, all these details are in the EH. So these can be easily found. If you've got a go-to scope, you should be able to lock onto that. In your field of view, you should have another bright neighbour, NGC 1272. That's a magnitude plus 12.8. So if you're lucky and the conditions are right again, you may be able to see half a dozen or a dozen other galaxies in that field of view. This is all within half a degree. So, and then along that area there's lots more galaxies. So this is an Abel cluster. It's in the Abel catalogue, and it's well worth having a look at. So the details are in the EH. If you have a look through there, it would be interesting if you could let me know that you actually find them. I'm pretty sure I've seen those galaxies before, the two I've mentioned, but I've never searched for the cluster because I weren't really aware of them. Yeah. So I will be looking for them. I've not actually seen them yet myself. I mean, in the spring, we've got the spring galaxies, right? I love them, right? It's so easy to find galaxies. Point your scope in the right area and you can't miss them. This area as well is another similar group. Not as big, but well worth a look at.
Excellent. Good. Do we have anything else for something? Just one more?
Well, that's a good question. Let's have another look. I mean, the only other thing really that is worth a look is Globular Cluster M79. It's in Lepus and it's just south of Orion. So Orion's a seasonal object, and the area underneath, the constellation that lies under it is actually Lepus, the Hare. So, you know, we know that the Dog constellations there, Sirius and all this surrounding that area. But in you know, when Orion comes around, there's lots of stuff around Orion that's well worth a look to. So M79 is a globular cluster. It's in the wrong place, really, because most globular clusters are surrounding our galaxy, and this one is in an area where it really shouldn't be. So it makes it an interesting thing. Dozens of stars can be resolved if you've got something like an 8-inch scope. It's a beautiful globular. It's at an unusual location in the sky. It's not around the galactic centre, so it's worth seeking it out while you've got the chance. Because in a month or so, it'll be gone. So
M79 is a globular cluster. Can I ask the table? Last question, promise. Ask the table. What's the difference between a globular cluster and an open cluster?
Yeah, that's a good question.
I think you've almost answered the question yourself, really. An open cluster is a loose distribution of stars in close proximity. Globular cluster. Yeah. A globular cluster is a tightly condensed ball of stars, really, gravitationally bound. I believe there are various classifications of clusters out there. I know William Herschel has covered some of these, but
tightly packed versus loosely packed.
Yes, there is a classification scale for them, but globulars are really quite condensed balls of stars, gravitationally bound.
Really old stars as well. They've got very little gas and very little dust in them. They're probably remnants of old galaxies that we've picked up.
We've nabbed on the way.
Yeah, and it's interesting, but there's about 150 that we can see, possibly 250, but we can't see most of them because we have to look through the rest of our galaxy to be able to see them. But we can also see globular clusters in the Andromeda spiral galaxy. I think is it G1 or M, something like this.
Yeah,
there's a massive globular cluster that's attached to the Andromeda. It's a satellite of the Andromeda spiral galaxy, and you can actually see it if you know where to look for it. You can look it up, and
I think they're common to most galaxies, to be honest with you. Globulars,
absolutely. But they've got really old stars in them. Yeah, and they're not too active. A lot of open clusters are relatively new stars, which are forming. The Pleiades are not very old at all, you know, and they're very active. They're blue. They've probably high metallitic stars, but the stars that you tend to find in globular clusters, as well as being tightly packed. There's some beautiful globulars up there. I love them. M13, M2.
And they're mostly hydrogen and helium then, those older?
Well, they are much older. I don't know quite what generation they are, but there's certainly very little gas, very little activity in those areas, just long-lived stars. Yeah.
Well, thank you very much.
Have you ever seen a globular cluster, Joe?
I've seen them 79. Through the dome upstairs.
Okay, well it's
really
it's
nice.
just a fascinating
really
thing to see because you've got a background which you've got stars dotted about and stuff like this, and if you look towards even the galaxy, centre of the galaxy, it's busy. But when you've got a globular cluster just hanging there like a swarm of bees, quite interesting to see.
There's a showstopper in the northern skies, northern hemisphere, I should say, is the great globular cluster in Hercules, known as M13. That is arguably the best one in the northern hemisphere. Yeah. I mean, that is stunning. It's about magnitude 6. You can see it with the naked eye from a dark side location. Binoculars, you see it as a fuzzy patch through a telescope. Of reasonable aperture, you begin to resolve the stars to the core. Largely, they appear like a fuzzy ball until you increase the aperture of the telescope. Then it becomes resolved to the core. What I mean by that is you see the individual stars all the way down to the centre, really. And on good seeing conditions from a dark side location, they can appear like photographs. Yeah.
Brilliant.
I'll just mention one thing. Okay. When I was younger than you, right, many years ago, one of the first things I saw through binoculars was the open clusters, the Perseus double cluster, and to see those two clusters abnormally close to each other just did it for me, and that drew me into astronomy. One of the things that really did for me. So the Perseus double cluster,
Yeah, it is a gorgeous cluster, isn't it? Though
It is.
That's enhanced by the fact you've got the Milky Way as a backdrop as well.
Yeah.
It really is a stunning location in the sky.
If you haven't seen them, Joe, they're like diamonds on black velvet.
Yeah.
Absolutely.
Beautiful.
That's exactly what it's like.
Choose your eyepiece wisely, because the two clusters, sometimes it's difficult to get both in the same eyepiece.
It is.
Yeah.
It is difficult. Up here on the 24-inch scope, if you're looking at the Perseus double cluster, it generally doesn't do it the justice.
No, it doesn't, does it?
It's not. They're like that, and you're looking at them like this. So it's difficult to see them as two clusters.
Okay.
Yeah.
Oh, that's really good. I'm learning a lot.
Most open clusters are within our galaxy and part of our galaxy. They're just background stars that to be formed at the same time and stuff like this.
And just to think, they've all come from like nebulous regions of the sky, like the Orion Nebula. So in time to come, millions of years, if not billions, the Orion Nebula, the gas will dissipate and you'll be left with a lovely star cluster. Yeah.
I look forward to it.
Something to look forward to. Yeah.
Well, I think if you are wanting to, if you want to challenge or if you want to know what's going on, just have a look in the EH and have a look at the looking up. That's what it's there for, really, just to encourage people to look up at the sky, have a list of stuff to see, so that when you do go outside, you've got some objects to actually look at.
Yeah. So if you want to find any more details about what Steve talked about, it'll be in Event Horizon, coming out in a few days. And if you're not a member, become one, and then you'll get the magazine.
Well, thank you, Joe.
Thank you very much. Thank you, Brendan. Thank you, Rob.
Cheers.
You're welcome, Joe. Cheers.
It's been a really good episode.
Brilliant.
Yeah. And don't forget, keep looking up. Santa's on his way.
And that is it for December's episode. I just have a few quick dates upcoming in December. We have the open evening on the 10th, and volunteers are still needed for that. On Wednesday the 14th, we have Barry and Tony's Christmas quiz for members. And also for members on the 20th of December, we have the Christmas Fuddle. I look forward to seeing you all at those events. I'll see you next time for the next episode of the Obscast.